Before we even really get into section 2.5, I'd like to talk about graphing inequalities. So let's talk about some examples of inequalities and how we graph them. So let's see some examples. So a good example would be something like x is greater than 3. So here's a number line, here's our number 3. In the past, when we've drawn something like this, like x is greater than 3, we would say, okay, here's 3, greater than means that we're going to point to the right. The other trick is that if our x comes first, and that's a big if, our inequality and our graph will point in the same way. See, they match. But that only works because the x is coming first. The other part is figuring out what symbol goes at the 3. Well, because it's a greater than and not a greater than or equal to, it means we actually don't want to include the number 3. So what we would do is put a big open circle at 3 that indicates anything after 3, but not actually equal to 3. That's what the big open circles mean. However, in this course, we start changing how we're going to draw our graphs. They'll look almost exactly the same, except for a little bit different. So it will still... We'll still have our graph starting at 3. It will still point to the right because it's still greater than. Nothing has changed. It's just the symbol that we're going to use. Instead of the open circle that we've always used, which was super nice and super understandable, we are now going to use a parentheses instead of open circles. So instead of open circles, we're going to instead use parentheses. Now, parentheses kind of have an issue because they can point a direction, while the parentheses need to point the way that the graph is pointing. This particular graph is pointing to the right, so our parentheses will also point towards the right. Now the question is, why would we do this to you? You already knew how to graph something. Why would we change it on you? No, it's not for fun. It's so that we can quickly write our graph in what's called interval notation. By reading our graph from left to right. And it would look something like this. Well, you'd read your new graph and say, well, if I read my graph, and I'm going to trace along it with a highlighter from left to right, I'd trace along it from left to right and say, well, it doesn't start until we hit here at 3. Notice when you do hit 3, though, it starts there with a parentheses. Comma, the question is, where does it stop? Well, let's continue tracing our graph with our highlighter. It keeps on going. Notice that arrow means it's going to keep on going in this direction to the right forever. How do we say that it's going to keep on going right forever? Well, that direction on our graph has a special name. When you're going towards the positive direction to the right here, it's called positive infinity. Notice we don't have to put a plus in front of the infinity. We just say it's positive because there's nothing in front of it. So we'll put a positive infinity. The question is, what symbol do we close this whole thing off with? We're actually going to close it off with another parentheses. Not because there's a parentheses at 3, however. We're going to use this parentheses on the end only because of the infinity symbol here. It's going to be one of our rules. Is if you have a positive or a positive infinity or a negative infinity, then you will always use a parentheses symbol with it. So we'll always use the parentheses symbol with it. let's try another one. Let's make one up here. Here's another example. What if we had something like x is less than or equal to -2? So again, if we were to draw our graph, here's -2. We're going to draw it both the old way and the new way. In old math classes, we would have said, okay, well, the less than means I'm going to be pointing to the left. And again, because the x came first, the inequality and the graph can point the same direction. The question would be, what was going to happen at -2 here? Well, the equal to here in past math classes would have meant that you would use a solid dot. Well, now in this math course, we're going to say, I don't want to use, just like we didn't want to use open circles anymore, we're not going to use closed circles anymore. We're going to use, well, we can't use parentheses. We're already using those for open circles, so we're going to use what are called brackets instead. So my graph will still point to the left, nothing new. It's just I'm going to use a bracket instead of a closed circle. They'll mean the same thing. So remember, brackets can point, so I can point my bracket towards the way the graph is pointing to the left. So it's going to open up the same way my graph is pointing to the left. Okay, and again, as a reminder, we're not doing this to torture you. We're doing this so that we can write our graphs in what is called interval notation. So let's see, this is supposed to give us a quick way to write out this graph we just drew. Well, let's see. We're going to trace the graph from left to right. Well, if I start on the left-hand side, notice I start tracing my graph where I've already got an arrow. Well, that means that that arrowed end goes off towards the negatives forever. That's our special one. That means it's a negative infinity on that left-hand side there. So, means I'm actually starting my graph with a negative infinity. Now, we just said a rule is that we're always going to use parentheses with negative infinity. Remember, that was our rule that we just talked about. Comma, now let's keep tracing our graph after that arrow and see what happens. It does stop. It stops here at -2. So I'm going to stop here at -2. But this time, notice I have a bracket, not a parentheses, at the -2. So I'm going to close it off with a bracket. Now this does look funky because why? You can now have parentheses on one end and brackets on the other. We can have mix and match. We can have a little bit of funkiness in here. So kind of keep that in mind that we can now have mixing and matching, and that is okay even though it looks funny. Let's try one more. This third one, I'm going to go ahead and just draw the graph right on top of the picture. And this graph would look like just a graph that goes in both directions, left and right. How would we write out its interval notation? Well, if you were to read it from left to right, is noticed, starting on the left side, we start with again, an arrow pointing to the left, which means you'd be starting with a infinity that's going towards the negative side on the left, so negative infinity. And it continues all the way to the right, where you have another arrow going towards positive infinity, so comma to positive infinity. The question is, what symbols are going to go on both ends? They're both going to be parentheses because they both have our rule that no matter what, if you have an infinity, you should be using parentheses. And this is basically the answer that we got in our last section for if something's an identity. Any answer works. Doesn't matter how big or how small, any real number works. That's what this negative infinity to positive infinity actually means. So, as a summary, what do we have? Is where in the past, so here's our summary, when we've had, let's see, less than or greater than symbols, we've used open circles. Now we're going to be using parentheses. In the past, we've had less than or equal to's or greater than or equal to's and used closed circles, and now we're going to use brackets. And special cases, if we have infinities of any kind, positive or negative, we're going to always use parentheses for those. And this is all hinging upon you reading your graph we'll read our graphs from left to right, which is exactly what you're used to doing anyways. That's how you read a book. That's how you're supposed to be doing your order of operations. That's everything you're already used to, working from left to right. Okay, so this gives you a pretty good background to get you started for section 2.5.